Welcome back to the classroom. My name is Mr. Wong and today we'll be covering Module 6, Inquiry Question 4 about talk. That's the turning talk, not talking talk. The 2020 HSC Physics paper question 28. Okay, or is it 23? Just quickly check. 23. Okay. So we have a graph, we have a motor that's connected to a 240 volt power source. We can see the angular velocity and the total torque. So as torque increases, the angular velocity is decreasing. We have an equation for torque here, which is this one here. We haven't seen this in the syllabus, but there's probably a purpose for us to analyze. These are all the different values each component represents in this formula. A circuit breaker cuts the current to the motor if the current exceeds 5 amps, meaning by if it cuts the current, it means the motor stops rotating. Okay. It says determine what will happen. So determine what will happen if the motor produces a torque of 2.95, show relevant calculations. That's what I want to try and do. Okay, so that means I will be using this equation here, interpreting the data from this graph to work out the value for I. I'm going to stay on this part of the document just to do a couple of quick annotations, and then we'll go to the actual answer section to write our response. So 2.95 is sort of like around here for torque. So we can say that the torque is around 2.95 and the angular velocity, just read it quickly, it seems to be 100. We know that V is 240. This N-like shape is the efficiency, so that's 0.3. Okay, so we should be able to substitute all the necessary values into this equation to get a value for I. What I'm going to do first is just rewrite all my equations out. What you could do also is just write them down here so you know what everything represents. Okay, angular momentum, rads. We have the efficiency at 0.3, and we have the voltage at 240. So substituting that into our formula. So this is our formula here. Substitute that through. 240, well, not 240, 2.95. 240 I times 0.3, and then we have an angular momentum of 100. Okay, so rearrange the equation. 2.95 times 100 divided by 240 times 0.3 gives us a current of, let's see what I had in my calculator, 4.097-ish, so round it off to 3 sig figs, 4.10 amps. Okay, now according to our question, if the current exceeds 5 amps, the circuit will cut off. Now we're smaller than 5 amps, which means the motor will continue to run. So what that means, so therefore as current is smaller than 5 amps, okay, the circuit breaker doesn't activate and the motor continues to rotate. Okay, and that's how you do a question like this. As you can see on the I guess, difficulties with this question is you are exposed to an equation that you're not familiar with. You'll just have to make do with the type of stimulus that they give you in the question. Try and interpret the data that's given to you and use all the little hints to help you come up with the answer for this conclusion here. If you found this video useful in breaking down the question and running through how you should approach it, please give it a like to support more videos like this to come out in the future. Thank you for watching, and I'll see you next time.